from Hanoi University of Science and Technology. And ladies and gentlemen, on this occasion, he is the moderator. Please welcome to Professor Chalerm Chon, Satiraport, Department of Software Engineering, Faculty of Engineering, Chulalongkorn University. Okay, and the moderator, Professor Chalerm Chon, this time, please to start your duty. Please welcome and thank you so much.
Okay, thank you very much for short introduction to all the panelists and myself. And very good morning to all of you who also attend here, both on site and online. I'm really excited and very happy to be a moderator of these sessions. And as you can see, the name or the title of our talk is very exciting. We are talking about the future of GNSS. So that's why we have to invite many experts in different sectors to be our panelists so that they can share their experience, idea, and viewpoint in any aspect. So without further delay, I would not be repeating with the introduction to all of the panelists. They are an expert. And if you would like to talk to him in person, try to capture them after the sessions. Otherwise, they will gonna be busy all the time. Yeah. So I would love to start with a very general questions to all the panelists here. Let me find a list of my questions because I make a list of some of the questions. After the short introduction by the MC, our session is going to be dealing with the GNSS and future use tech. So I'm thinking about starting with maybe two general questions to the panelists here. And the first question would be dealing with the area that GNSS technology would be popular in the future. Maybe you can share your idea about the current future utilization of GNSS, your field of work, or even in your country, or even in a global scale. Maybe I could start with Professor Shibasaki first. Yeah. Yeah. Yes.
Okay, thank you very much for introducing me. And actually, I have provided PowerPoints.
Can
Would
you
you kindly run my
open the
slide
PowerPoint for
together with the
Professor
movies?
Shibasaki?
Yeah, okay. Anyway, before starting the slide, yeah, anyway, please start the slide. But until then, let me summarize what I would like to talk about. Is what I would like to emphasize is the kind of security or trustworthiness of the GNSS services. Yeah, of course, when we say trustworthiness, yeah, of course, have many aspects, including the errors or accuracy or whatever. But what I would like to emphasize is something like a spoofing or cheating of the locations or whatever. Because with the advances of the very small, cheap GNSS devices, we can now monitor of the movement of people or vehicles on the real-time basis. Of course, we should not forget about the contribution of the high-speed network connection or connectivity. But nevertheless, with the help of the real-time data, we could actually see the current status of the cities on the real-time basis, and then we can make kind of predictions or control, and that is really important. because just looking at the situation, just monitoring the status, yeah, of course, it would be quite useful. But if we cannot do anything to improve the situation, we have no power, or anyway, kind of, let's say, we are kind of powerless. Yeah, so then the real-time readiness is quite important. So then next stage would be something like optimization or control or whatever. Then the real-time position will become very important. In case of Singapore, Singapore actually is reading the major cities in terms of the electric road pricing. Yes, so then, yeah, anyway, okay. Yeah, thank you very much. Next, please. Actually, this slide just illustrates how the real-time monitoring and also the prediction made it possible with the advances of the GNSS. Next, please. And this would be a very good example of the Singapore. This is a kind of dynamic road pricing, and it lead to a kind of optimization of the road traffic control. Thank you. But actually, you could see the gantries. Is now rapidly shifting to the GNSS based ones. So anyway, it's something like a dynamic optimization. So then the GNSS data or the location is become very important, because if you can cheat the location, you can save money, right? So then the security or anti-spoofing or cheating would be quite important. And also at the same time, the high-speed data communications also requires a very precise data synchronization. 5G sometimes requires something like a 20 or 30 nanosecond time synchronization. It's very strict and a very precise requirements. And so then the GNSS plays a very important role in such sort of the precise time synchronization. And but again, as you know, that the GPS or many of the GNSS signals are kind of open signal. So for example, this kind of old iPhone was located in the conference room of Jakarta. But anyway, we conducted a kind of demonstration of spoofing. So you could see, although the mobile phone did not move apparently, but it's just right to the palace and rotating around the, let's say, Gate of the Triumph. Yeah, so anyway, this kind of information could be very easily generated with a very cheap hardware or kind of devices. So then, okay, we would like to test, or we would like to demonstrate how the authentication or certification of the GNSS location data is needed. I believe that QZSS or Michibiki will start the very first location certification or authentication services in 2024. I believe that it could be a very good test case in exploring the applications of the location certification or the authentication. Okay, thank you so much.
Thank you very much, Professor Shibasaki. He addressed the very key words and also happened to be exactly the same as this keynote speak this morning from Professor Chris, that trustworthiness is one of the key point that we have to be really beware of that kind of thing. Professor Shibasaki also showed us some of application that we could use from the location from GNSS, and he showed us some example from the government of Singapore data. That's why I'm going to move to Dr. Victor to share your idea to the audience, please.
Thank you, Professor Chun. Thank you, the organizer, for having me here in Hanoi today, in Chiang Mai today. I would like to talk about future usage based on 3 areas. One is, of course, the traditional area of survey and mapping. I think that's very common to everyone. The other area is, of course, navigation and tracking, and lastly, monitoring. So these 3 areas. Of course, from my perspective, the background coming from the geospatial and geomatics, the key application of GNSS have to be related to geospatial. We always say that GNSS is a geospatial technology, while GNSS is really not developed or invented for geospatial purpose, but geospatial has been using GNSS to collect a lot of data and in mapping. So there's a strong connection between GNSS and geospatial. From the usage perspective, going into the future, I think I'm talking about from the perspective of Singapore. There's a lot of future mobility that we are looking at. Future mobility involves shared mobility, green mobility, as well as autonomous mobility. These are the 3 areas of application which very strongly tied to the usage of GNSS, particularly precise GNSS or precise positioning. So a few key terms that come into my mind that in terms of the development, we have the autonomous vehicle development in Singapore that's on the road. We have the autonomous mobile robots development in Singapore that is not on the road, maybe on the pavement and going into a small area, congested area. In Singapore also, in terms of smart construction, the usage of robots in construction also use a lot of precise GNSS, not just for horizontal positioning, also for the 3rd dimension, for the height monitoring and height positioning. So smart construction is a very important area in terms of usage for GNSS. The second area that I want to talk about is monitoring. I think GNSS is very important and increasingly important going into the future in terms of the usage for monitoring. And in this case, we are talking about monitoring for the purpose of climate crisis. We use the data, we use the information to look at land movement, vertical land motion, as well as looking at sea level rise monitoring. So, as Professor Chris Resource mentioned, that there are many application of GNSS beyond just positioning into space weather and many other areas, or atmospheric monitoring. So GNSS is also very important for monitoring. And last but not least, the traditional area, which is the survey and mapping, creating maps, developing precise geospatial data. And this area is particularly important is because when you have your precise positioning, your centimeter level positioning, you need your centimeter level maps to work with your centimeter positioning in order to achieve smart nation applications. So I think that's what I want to share today.
Thank you very much, Victor. He shares 3 key points from his perspective. And maybe let's come back to our MGA chairperson that he might have some experience and idea to share with the audience. Please, Satoshi.
Thank you, Professor John. So, I have been deeply involved in the Japanese government development quadrant satellite system. So, I would like to share with my experience. So, and inside of the future, the perspective of our system. So, now we are providing a kind of espace-like system. So the not only the providing ranging source services, so which have interoperable signal with other GNSS, but also we are providing so the augment service. We are so transmitting error correction message through QGSS. So we would like to improve availability and so the accuracy and the reliability for the satellite navigation applications in the region. So very important trends. So Chris present. So GNSS have a vulnerability and shortcomings. So we would like to the overwhelming that shortcomings. So also the Professor Shibazaki mentioned the importance of a trustworthy signal. So QGSS will provide messaging authentication service in a couple of years. So we are assuming so that in 2024 or 2025. So we will start message authentication service from QGSS. Also, so we will providing such NMEA for Galileo and the GPS with using our L6 signal. So that could be one kind of a solution, not covering all application, but we are promoting the future QGSS application also. And according to the application, we are facing a very aging society, especially in Japan. So autonomous machinery, the agriculture, and also autonomous driving. So it could be a great a benefit for utilizing the precise GNSS application. So the Japanese government will be providing more precise, more reliable signal and services with using a QGSS. So I'm proudly to contributing to this activity. Thank you very much.
Thank you very much. We heard about the new authentication service that is going to be available very soon, maybe next year or next 2 years. That could be benefit to many of Asian countries also, not only in Japan, I believe. Yeah. So I'm really excited to see that. And let we move to one of panelists from Vietnam, Professor Vince from Hanoi University of Technology of Science and Technology. Please share your
Thank you, Professor.
idea.
From my experience and my point of view, I would like to share with you that some applications first of the mass market GNSS receiver in my country. The story started from 2014, about 10 years ago. The government started to force the use of at that time we just simply call GPS tracker. Yeah, thankful now we know about the GNSS term, but at that time people just call that GPS. Okay. And the government started forcing the use of tracker on the vehicles. And at that time, only 200,000 vehicles are equipped. But after almost 10 years now, the number is around 1.5 million. So that a huge amount of real-time traffic data go into the systems. And that system help a lot in reducing the traffic accidents through the 10 years. And also that huge amount of data now, it's actually not yet mining to serve the other purpose, but it could be serving as traffic real-time information. I think if it is happen, it's made better than the Google traffic now. Yes, that is the experience of using the mass market receiver in our daily life. for the management purpose, not for personal purpose. Now we use Google Map. And also from my point of view, I think the precise receiver will be very soon popular in a very near future, because as in we may know that recently eBlocks or Broadcom has already produced a multi-frequency receiver with very low cost. I think 10 times cheaper than several years ago. Also last year, Qualcomm and Trimble announced a collaboration to integrate the precise engine into the Snapdragon 800 family. So I think very soon we will see the precise navigation available on our mobile, our laptops, together with the augmentations with course network or Lex Madoka from the satellite, or the Galileo high accuracy service. I think the precise navigation will be very soon booming in a very near future. That is my point of view, from the mass market to the high accuracy service. Yeah.
Wow, really surprised to hear that you have a lot of users, at least millions, trucks and others. It's already 5 million, right? Okay, yeah. So Vietnam is one of the countries moving toward to the use of geospatial technology. After the general question, I would like to move to more specific questions for each of panelists. You might see that in our MGA conference here today, it's our first time to start talking about the LEO PNT. And we can foresee the new era of GNSS technology. My question to Satoshi is that how would our world be changed with this new emerging technology? Please share your perspective.
Thank you, Professor Chen. So we are sort of having a sort of dedicated session for the LEO PNT tomorrow morning. So I invited four speakers. So the two from commercial providers, so the both in the US and China, and also the one commercial providers, but the business that came from this, not only using a GNSS signal, but also LEO communication satellite signals. So like the SOOP, signal of opportunity technologies. And also, invited ISA, the expert. They are investigating the multi-layers and the hybrid constellation design in a future Galileo update. So I would like to invite audience to join the session. So LEO PNT has a very strong point overwhelming the GNSS shortcoming, the vulnerability, the very weak signal. So the LEO can transmit much more higher power, and also the very fast dynamic to support shorter convergence time. So it is a very shortcoming for utilizing a signal point positioning with carrier phase. So the need the ambiguity resolution with some convergence time. So, and also, with using the LEO communication signal such as the Starlink. So the signals independently away from far from the signal, the frequency band with existing GNSS signal in L-band. So this could be a great redundancy, robustness for the services. So there is many the possibility to use this LEO PNT services. So that's my point. So I would like to share here now. Thank you.
So So look like we're gonna have Leo PNT to be a complement of GNSS that to fulfill the shortcoming of GNSS signal, right?
Yeah, so the in the early stage, early phase in near future. So yeah, GNSS complementary. So it could be a sort of first goal for DO PNT service. But so that in the more future, so yeah, kind of an alternative. So the backup system or full backup system of GNSS, the independently providing. So yeah, PMT. Even if the sort of all GNSS signals are denied in the some reason, so the jamming and so yeah, some natural so the interference. So it system can be provided so the PMT services. So that's my perspective.
Thank you very much. As we know, Singapore is one of the countries that advance in utilizing GNSS technology in mobility sectors, especially. My question to Dr. Victor is that how much expectation do you have for more advanced mobility sector by GNSS? What do you expect in the future?
So I shared about future mobility in Singapore. We know that GNSS technology as well as geospatial technology are the two enablers to advance the future mobility, which covers shared mobility, green mobility, as well as the autonomous mobility. So from an autonomous mobility perspective, there's a lot of development. Not very, we wouldn't see that this is going to be implemented soon. It's still in development. Certain areas in Singapore are designated for the test. But this is an ongoing and continuous test. On the other side, there is also autonomous mobile robots, which I think most of the people believe that this is going to happen in a mass market very, very soon, because this is less controversial. It goes into more areas, especially in the area of last mile delivery. You know, robots sending food or sending delivery to customer. Having said that, this is an area where GNSS, especially precise GNSS, can be used you know, in a very beneficial way. And all this is not just the positioning. When we talk to the developers of autonomous mobile robots as well as autonomous vehicle, GNSS positioning always is the last thing that in their mind, because to them localization is a big topic, including using other techniques like LiDAR, radar, and other things. So there are a lot of debates in terms of which is the primary technology, which is the secondary technology, and then all this conversation continues, right? So I think that is what the development in Singapore is all about. But the last area, which is not so more, is a smart construction. I think this is the area where it's also very important, where GNSS is being used in the area. For example, in automated piling system, automated crane system, we are using this GNSS technology, especially the precise GNSS, not just to build buildings. We are also using it to avoid accidents. You know, for example, in terms of precise GNSS on some drilling machine, and we go into a geofencing, prevent the machine in drilling out some utilities. Right? So these are very innovative applications. So some machines that we don't want it to go into certain areas, we can actually do geofencing using GNSS to prevent accident and damage. So that's what I want to share.
Wow. Very interesting applications you mentioned. Professor Wins has been dedicated to GNSS R&D and promotion of the GNSS application activity for quite a long time in Vietnam. And my question to Professor Wins is that how does you see the difference in the current societies with GNSS and what is the trends in your countries?
Still take my example, the previous example to explain you that when the current status of using GNSS and the compared to the previous, I mean the periods before 2014, and I give you the an example number that I have slide, but actually not showing here. Using the GNSS in managing the vehicles have reduced the serious accident almost up to 20%. Yeah, that is a very meaningful numbers for the use of GNSS from the past to the current. And also, I think the government realized the potential of that. I think 1 month before this event, the government also issues another use of the mass market receiver to use in the monitoring the training driver. It means that now if you apply for a course and you have to drive, they will monitor you. After that, they know how many hours and in which road, at which speed you have practiced. And if you're satisfied, they will put you to the final test. Also, I think in the last 2 years, the government course networks completely constructed and start providing the service to the user. Just like in Singapore, I think currently most of the users are from the surveying and mapping and constructions area. But I think in the near future, the autonomous vehicle can be very big players in that area.
Just to ask you a more
Yeah,
question,
yeah.
because you are using the GNSS to manage large amount of vehicles in your countries.
Yes.
Did you experience a lot of jamming and also spoofing?
Okay. About the jamming, spoofing is not very popular. Yeah, but jamming in the last 3 years, I think, we collaborate with NSL in UK to monitor the signal just around our campus. And how many jamming events can you predict per day?
Per
day.
Per day, I would say 20.
1,000.
1,000.
Yes.
Oh,
That
wow.
is the data from the NSLs they provided us after they record the data and analyze data. They even analyze the spectrum of the signal, and they classify different kind of jammers are using on the street. Yeah, that is a fight because you know that drivers are not very happy being monitored by the government. Yeah, but I think the government improved the laws, the regulations to try to avoid that, because if now if the vehicle is not sending signal into the server for some fixed period of time, then you may be punished. Yeah.
Wow, really significant number of jamming in your
So
countries.
very good environment for doing jamming detection, jamming mitigation results in that area.
Okay. And again, Professor Shibasaki also been very advanced in utilizing satellite data, including the GNSS in many applications. And for quite a while, my question to Professor Shibasaki is that in Asia region, we are accelerating in digitalization. And how do you see the contribution of GNSS in that kind of sector?
Yeah, anyway, thank you very much. That is a very broad question. But basically, as for example, Dr. Ku or Victor has emphasized, something like autonomous mobility or autonomous robots And so in that sense, the combination of the real-time localization or positioning with automated autonomous control might be a very important key technologies, because that has a huge impact on the society for safety, and also probably sometimes to complement the let's say limited human resources. And also at the same time, the 24-hour operations would be made it possible to monitor the forest or to cultivate even the crop field or whatever. But at the same time, again, the security or the safety again, because once the robot actually have some sort of issues, it could kill or at least injure the people, right? So anyway, such sort of the aspect will be or should be highlighted, especially by the technical or technology experts. Yeah, thank you very much.
Very interesting. Thank you very much. We still have maybe 10 minutes of time left in this session. I would be really happy to ask the audience to raise up any question you would like to ask to any specific panelists. Is there any question from the floor? Okay. Maybe anyone can give him a microphone. Please introduce yourself and then raise up a questions. Maybe it's faster to come up to the stage.
Hi, morning. My name is Ben. I'm from Singapore. I work for the Science and Technology for the Homeland Ministry of Home Affairs. So just to add on to what Victor has said in terms of the autonomous mobility. So for us, we have been deploying robots on the road, at the sea, and even drones to augment the national security in Singapore. So in this area, one of the main concerns, main issues that we are facing is integrity, because all these systems are using GNSS. So how do we operate all these systems in the urban environment? So the issue we face is how to have precision and accuracy in our environment. So this is the issue that we are facing now. How to launch a drone next to a building autonomously without crashing onto the building. So these are the observations we observe. And we are still trying to resolve it, because most of these systems are using GNSS as part of as the core navigation sensor. And operating all these systems operationally, we can't add in more sensors. Add in more sensors, the duration will be cut down. The whole system will get too heavy. Power consumption goes up. So I just want to share what Victor has shared with everyone, that we are looking into this as well in terms of national security in Singapore.
It's not really a question, just sharing of the experience and idea on the use of GNSS, especially when he tried to fly the drone nearby the building, and yeah, afraid that it's gonna hit the building or something. Yeah. Anyone else would like to share? Please, can you please come up to the front, please? Okay. Yes.
Wireless doesn't quite work. Thank you for the very interesting talks. Chris, in his keynote speech, mentioned that GNSS is primarily used for outdoor location. We've been talking for years about indoor location. And as a regulator, oh, sorry, by the way, I'm Dominic Hayes. I'm from the European Commission representing the Galileo system. As a regulator, or one of the roles I do as a regulator is to minimize the interference that we have in band. And one of the challenges for indoor navigation is so-called pseudolights, which often emit signals in the GNSS band. So I think the last thing we want is to encourage in-band transmissions that could potentially interfere with outdoor GNSS reception. So a question to the panel is, how do you think we can overcome this challenge to enable indoor navigation without inadvertently causing problems for outdoor navigation? Thank you.
Very interesting question and also very difficult for me to answer. So I would rather pass to the panelists. Anyone would like to address this? Ah, okay. Maybe Victor could share some of your idea on that.
I actually don't have an answer to that. So we are actually interested in indoor navigation, indoor tracking, because in Singapore, it's very dense city. Not all the time activities happen outdoor. So sometimes indoor, sometimes outdoor. How do we resolve this? We are looking at many other geospatial technology like SLAM and other things. Not so much in pseudo-light. I think this is a technique that we have been looking at many years back and have dropped that to a certain extent in terms of application. Again, I think based on my experience working with the autonomous mobile robots, people is really augmentation in terms of the different technology on board of the robots, including GNSS and LiDAR, radar, IMU, and many other things for that purpose, even though all these would add a payload to the robots. Yeah, but that's still the way that we are looking at this point of time for more effective and efficient localization going forward. Also, I think from the geospatial technology perspective, visual positioning system is also another one that I know that the industry is looking at very rigorously, and these are some of the other technology, other positioning technology that Singapore's government are looking at.
Thank you very much, Victor. I'm going to ask Satoshi. So now he's here.
I would like to share with you my experience. So once I developed the indoor messaging system called IMES. So I had a big issue to promote that technology. So I believe we can operate correctly the IMES in indoor, so to avoid harmful interference with outside GNSS signal. So we also developed some management system. It registered each transmitter's position and location in our server, and we create some activation code to that transmitters. So without this activation code, any transmitter can send the signals. So I believe we could control at that moment. But several discussions with our colleagues at that time, we utilize the PRN code provided by US. But US changed mind to protect the signals in band. So we gave up to continue to use the GPS PRN code for our IMES system. So yeah, most important finding from the discussion with US. So yeah, the protection in band, air band is very important for the avoiding harmful interference. So our service GNSS can be utilized for the safety life of applications. So we need to avoid the intentional interference, the jamming. So they are afraid if Japan can correctly control that usage, but someone misuse that transmitter or jammer. So we couldn't assure a solution at this moment. So this is my experience. So technically, we may control with using such kind of latest authentication, some kind digital solution. But how to avoid the misuse of such kind of technology could be a challenge of us. But recently, there's a many of technologies for indoor positioning. So we can't rely on the indoor transmitters in the same band of GNSS. So just my final comment. Thank you.
Thank you very much, Satoshi. Would Professor Win like to add anything?
To add one more comment, because this is a very technical question. Okay, so I think the purpose of rebroadcasting the pursuit rank in the indoor environment so that the user can use the current existing, receiver, and don't have to equip with any other else, right? But I think as I know that that is not the only way to perform the indoor positioning. And as the emergence of the 5G network with currently with the sub-6 GHz band, and could be the millimeter wave later. And as I know that such kind of signal is very good in ranging capabilities. So the 5G itself may provide another indoor navigations instead of rebroadcasting with the same frequency band as the GNSS band. So I think it could be a good solution, even though right now we don't see any, existing solution yet. But I think it's 5G potentially can be a good indoor positioning system without interfering the real GNSS band.
Yes, still a lot to do for researcher like us. Unfortunately, we are coming up to the end of the session time, I believe. And if the audience would like to further discuss with any panelists, please feel free to come after the stage. And if you have any questions from the online audience, please leave your questions in the chat box. We will try to reply to you as soon as possible. And I would like to thanks to all the panelists to be here and sharing a very valuable experience and idea with all the audience, both in the room and also online. Thank you very much.
Thank you.